Hello, everyone. So thank you for joining us today. My name is Rafard. I am your Director of Field Applications for the Analytics Division here at Unchained Labs. I will be your moderator today, and I'm just very glad that you've decided to join us, so thank you. So before we get started, I want to let any of our customers on this seminar today and watching know that we are dedicated to supporting you throughout this challenging time. And so if you need something or think of anything that we can help with, please don't hesitate to get in touch with your local sales rep, your application scientist, or any of our engineers, and you can contact us directly or through our website. Okay? So we're just pretty much ready to do anything we can to help you. We've been hosting virtual seminars, virtual demos where we actually run your samples in real time, and you can follow along as we load the samples, set up the experiment in the software, and review the analysis with you and the results in real time. Okay, so we'll have a Q&A at the end of the presentation. So I'm going to ask that you submit your questions by clicking on the Q&A in the Zoom navigation bar at the bottom of your screen and type your question. And we'll get to as many of them as we can. And anything that we don't get to answer, we'll follow up by email with the answers that you've requested. And so now I'd like to introduce your presenter today. It's Keith Solomon. He's one of our stellar application scientists. And so Keith will talk to us today about the Lunatic and Stunner platform and exactly how we can use them to do plate-based high throughput B22 KD measurements that are both accurate and fast. And now I'll hand it over to Keith. So thank you.
Welcome. My name is Keith Solomon. I'm a field application scientist at Unchained Labs. My territory includes New England and the upper Midwest. So if you happen to reside in one of those states, you might have interacted with me in the past. Today, I'm delighted to present to you high throughput KD B22 screening using the Stunner platform. The Stunner instrument is uniquely situated to perform high throughput KD B22 screening. It is the only instrument that makes the two critical measures necessary to do KD-B22 analysis. It measures concentration extremely accurately, as well as doing dynamic light scattering. Those are the two measures that you need. Stunner provides both of those measures and is the only instrument available that can do so. Moreover, because it's a 96 well plate formatted instrument that is amenable to robotics, it can do high throughput KD-B22 analysis unlike any other instrument available. One of the great features of the Stunner instrument is the design of the Stunner plate, which is a 2 microliter volume plate with two fixed path length cuvettes of 0.1 and 0.7 millimeter. Essentially, the 2 microliter sample is added to the well, and a microfluidic channel brings the sample to a hydrophobic barrier where it sits. Once the Stunner plate is placed within the instrument, both cuvettes are read empty. Then a pump turns on and brings the sample to both cuvettes. The 0.1 and 0.7 millimeter fixed path length cuvettes are used to measure the very accurate and precise concentration determination provided by the Stunner, while the 0.7 millimeter path length cuvette is used also for DLS analysis. If you were to fill all 96 wells of a Stunner plate, you could get concentration determination in 12 minutes. If you would also like dynamic light scattering, you can get all of that information in 1 hour. And remember, the Stunner plates are SBS compliant plates and are completely amenable to robot liquid handlers and they can also be placed in the instrument by a robot and followed by barcoding. The DLS data that you get from the stunner instrument is ISO standard data. You get intensity distribution, mass distribution, as well as correlation functions. And on top of that, you also get the concentration of your analytes. Again, making the stunner instrument a one-of-a-kind instrument ideally suited for doing high throughput B22 analyses. There are various ways to analyze samples on a stunner instrument. You can simply do classic UV-Vis quantification. You can use unmixed applications to deconvolute complex samples that contain perhaps salts and nucleic acids. Of course, you can use the dynamic light scatter to characterize the hydrodynamic diameter and the polydispersity of a sample. And with the stunner, you can also create your own applications using Homebrew. For the purpose of this talk, we're going to focus on the UV-Vis aspect of the stunner as well as its dynamic light scattering capabilities, both critical for measuring KD and B22. As I said before, the stunner produces ISO standard DLS data. Here you can see that there's a homogeneous population with no aggregates producing a pretty tight hydrodynamic diameter. On the other hand, here's another sample with some degree of polydispersity, but you can get accurate hydrodynamic diameters of both peak 1 and peak 2 using the stunner instrument. This is what the output from the stunner instrument looks like. You get your intensity distributions, your mass distributions, your correlation functions, as well as your concentration determination for all of your protein analytes. Before we explore using the stunner for KD-B22 analyses, let's take a few minutes and talk about how dynamic light scattering works. First, what can DLS do for you? It can measure the average size of particles in a sample, the hydrodynamic diameter. It can measure the complexity of samples, or its polydispersity. And it can look at both of these things as a function of stress, time, and temperature. DLS is a very sensitive technique for measuring colloids. It's done in solution. You don't need to do buffer exchanges or anything like that. As long as you know the viscosity and the refractive index of your buffer, you can accurately calculate hydrodynamic diameters. And you only need a small amount of sample to complete a DLS analysis, especially using the 2 microliter plate format of the stunner instrument. DLS is a very sensitive technique for the presence of aggregates. Because it scales by the power of 6, a particle that is 10 times larger produces 1,000,000 times more light scatter. So it's very sensitive to the presence of large aggregate species. The reason that DLS works is because particles in solution are constantly in motion. We call this Brownian motion. Small particles move more than large particles. It makes a lot of intuitive sense, and it's perfectly compatible with our understanding of Newtonian physics. Using DLS, you're actually measuring the diffusion of particles in solution. And again, small particles diffuse faster than large particles. Because of the work of Einstein and the creation of the Stokes-Einstein equation, we can relate hydrodynamic diameter to diffusion and calculate the hydrodynamic diameter of unknown proteins. Now, this assumes a spherical shape to proteins. We know that's not completely accurate. Most proteins are not spheres. Nevertheless, the application of DLS technology has proven quite beneficial to understanding the biophysical characteristics of protein analytes. Again, the basic idea of DLS is that small particles move more than large particles. You can measure the intensity of scattered light. If that intensity fluctuates rapidly, then you know you're looking at a small particle. If, on the other hand, that intensity fluctuation takes a longer period of time, you're looking at a larger particle. Consequently, not only can you measure the diffusion of both large and small particles, but you can differentiate between the two. And that's basically how dynamic light scatter works. It's looking at fluctuations of intensity as a function of time using a very short time scale in the nanosecond range initially. Okay, now we're going to look at B22 and KD. When you do KD analysis, you're using dynamic light scatter. When you do B22 analysis, you're actually using the dynamic light scatter laser and the avalanche detector in static light scatter mode. There is no time function for static light scatter. It's just looking at the intensity of the light. On the other hand, when you're doing a dynamic light scatter analysis, the intensity of the light doesn't matter. It is the fluctuations of intensity as a function of time that you're measuring. When you do KD-B22 analyses, you're hoping to derive a positive or neutral slope. A positive slope suggests that the protein analyte prefers to interact with solution as opposed to self. A neutral slope indicates it has no preference. A negative slope, which is not a good finding, suggests that those proteins prefer interacting with self, that there's a preference to interact with one another as opposed to solvent, which predicts aggregation events. Here's an example of looking at the G1 monoclonal antibody in a 20 millimolar histidine buffer with no excipients. You can see here in this formulation, both KD and B22 produce positive slopes, suggesting a repulsive force between the protein molecules or a preferential association with solvent over self. Adding 20 millimolar sucrose somewhat improves the B22 slope and doesn't really change the KD slope, but certainly this result suggests that sucrose is not having a bad effect on the protein analyte, and it may actually be having a positive effect on the protein analyte. In contrast, adding either NaCl or arginine to this formulation causes KD to become negative, suggesting a propensity to self-associate and portends aggregation, while B22, in one case the NaCl flattens the line, so there's no longer a positive slope, and in the case of arginine, it turns quite a positive slope to something that is almost neutral. Again, not optimal for the formulation of the G1 monoclonal antibody. If you recall my webinar from 3 weeks ago, I showed for 4 different monoclonal antibodies that the addition of arginine and NaCl to the formulation caused aggregation behavior. Here we're looking at static light scatter using the Uncle's 266 nanometer laser and are able to show small aggregate formation as a function of formulation. Similarly, looking at the Uncle's 473 nanometer laser used for static light scatter analysis, we're able to show large particle formation, again as a function of formulation. When arginine and NaCl is added, you get large particle formation. When other formulations are used, you only get nominal large particles, suggesting that the addition of arginine and NaCl causes colloid formation. Again, looking back at the KD-B22 data generated from the stunner, here we see again that adding NaCl and arginine changes the slope of KD from positive to negative, supporting the concept that for this protein, these excipients may have a negative impact on its colloidal stability. Here we've put all of that stunner data, we've exported it to Excel and replotted all of the lines in a single graph. Again, we can see, looking just at the B22 data, that adding either arginine or NaCl has a negative impact on the slope and consequently may portend more aggregation behavior than in the absence of either of those excipients. Here's another example looking at the KD of Lysozyme, how the addition of excess NaCl seems to change the slope in such a way as to cause the molecules to have a propensity to self-aggregate and portends potential aggregation behavior in this formulation. Here is another example looking at the B22 analysis of BSA on the stunner. Here we have 2 different pHs. We can see that changing the pH from 7.5 to 4.6 changes the slope of the BSA, but it's still positive. We don't quite yet know enough about B22 analyses to granulate it so finely as to say how much better pH 7.5 is to 4.6. They're both positive slopes. In this final example, we're looking at KD and B22 analysis of the NIST monoclonal antibody on the stunner instrument. As you can see here, in this formulation, we have both positive slopes for KD and B22. And if this was a development project, these formulations might get the go-ahead to move to the next stage of analysis. What have we learned? Stunner is a low-volume, 96-well plate-based instrument that is amenable to automation. Stunner is unique insofar as it is the only instrument that makes the 2 critical measures required for accurate KD-B22 assessment: concentration and dynamic light scatter. Stunner KD-B22 can differentiate between different formulations, and we also learned that arginine and NaCl are 2 excipients that may produce negative KD-B22 slopes and portends reduced colloid stability. That completes our assessment of using the Stunner platform for KD-B22 analysis. In a very few minutes, you'll be able to pose questions of me, and hopefully I'll be able to provide cogent answers. But before we do that, I'd like to announce new software for the Lunatic and Stunner Instruments software version 7.0 that has a lot of interesting features, especially if you're working in a GMP, GLP environment. We've improved the accuracy and the precision by which the Lunatic and Stunner measure the concentration of analytes. Here we're showing the measurement of IgG from 0.2 to 200 milligrams per ml. As you can see, there are very small error bars in the measure at any of these concentrations, and the result is quite linear with expectation. Version 7.0 also has a new kit associated with it to allow you to know the accuracy by which the Stunner or Lunatic platforms are able to measure protein concentration. These samples, called the fundamentals, are 5 different concentrations of tryptophan. And as you can see, looking at the measurement of the concentration of these tryptophans, the target concentration and the measured concentration are extremely linear, producing an R-squared value of 0.999, suggesting the beautiful precision and accuracy of the Stunner and Lunatic instruments. If you were to purchase a new instrument, you also have the ability to do a performance verification check using new standards provided by HELMA, which can be used to verify the precision and accuracy of the Stunner and Lunatic instruments for GMP and GLP lab settings. If you're still curious about these software upgrades, there is an application note available on our website, as well as a technical note. And please tune in to a webinar on May 14th, where this new software will be explored in depth. I want to thank you very much for your time, and now I'll take your questions.
Thank you very much, Keith. That was a great presentation. And I also want to thank everyone for attending today. I just want to get started by answering some questions that have been submitted, actually. So let's see. The first one is, what is the relationship between B22 and KD?
Thank you, Rafad. That's an excellent question.
Sure.
B22 is an essential part of KD. The KD has both a thermodynamic and a hydrodynamic portion of the equation. The thermodynamic part of the equation is B22 and molecular weight. The hydrodynamic portion of the equation is what causes KD values to change as a function of formulation in a way that B22 values do not. So they're highly related measures, and B22 is part of the KD measure.
Thank you very much, Keith. Let's see. Someone said, how can you alter a negative KD B22 slope?
Right. It's the way to alter a negative KD slope is by virtue of reformulation. And that's a really easy thing to do. There are lots of different buffers you can use at a range of pHs with all sorts of different excipients that may alter KD. And as you can see from the presentation that we just made, we're able to easily alter KD by adding either NaCl or arginine. It's harder to change B22. Generally speaking, if you want a significantly altered B22, you need to go through a process of sequence optimization. Obviously, that's a lot harder than doing a formulary screen, but nevertheless, you can alter B22 by changing the sequence of your protein analyte. I cannot hear the question.
Can you hear me now?
Yes.
Right. The question was, how does KD B22 analysis work with high concentration samples?
It doesn't really. There are definitely assumptions made in KD-B22 analysis where the crowding effects of high concentrations are not represented well. Consequently, Chris Roberts at the University of Delaware has developed a measure called G22, which can be used similarly as B22 for high concentration samples. So if you're doing a switch over from an IV to a sub-Q delivery, you need to achieve concentrations of 150 to 200 mg per ml, then you'd probably be better off using G22 analyses as the B22 KD assumptions are not met by high concentration standards.
Thank you. Okay, so I'm going to pull some questions from the chat as well. Looks like someone asked, how does it handle evaporation if it runs for 1 hour? That was from Peter Walsh.
Well, that's a very good question. So the way the stunner plates are designed is such that they're actually closed at the top. So once you put the sample in the well, a microfluidic channel will take the sample into up to the hydrophobic barrier, as I discussed during the talk. And at that point, the evaporation is difficult. So certainly you don't expect evaporation in the 1 hour of analysis. That's not going to happen. If you fill a plate and leave it for more than 3 hours before reading it, you might run into some issues. You may have some evaporation. Consequently, you may have some gelation, and we don't recommend doing that. If you wait up to 2 hours, though, before loading, you should be good. There shouldn't be much evaporation, if any at all, and your samples will be read correctly.
Thank you, Keith. Let's see. One said, have you done comparisons between the results of this instrument and other instruments on the market? And it looks like it pertains just to general DLS questions.
I'm not privy to direct comparisons. We're not really in the business of direct comparisons between our instrumentation and other instrumentation. We have compared the stunner DLS to the Uncle DLS, another instrument that we make. And the slopes are basically the same. There are some little tiny differences in numbers. Remember, the stunner is going to be a little more accurate, and the error bars are going to be smaller because it's taking the direct measure of concentration of the samples that you're doing the DLS on, as opposed to having the samples read on one instrument and then read for concentration, and then read on another instrument for DLS, which is less efficient, and you can run into small variations that affect the accuracy of the result. So I can't really answer the question between whether or not how our instrument performs against other instruments created by other vendors, but I will tell you that all our instruments meet the same standards as other instruments, and you would certainly expect to find very little difference in the application of DLS on these various instruments. They all use very similar methods and algorithms. But the stunner is unique for doing KD-B22, as it is the only instrument that will measure your concentration at the same time it is measuring your DLS.
Thank you. And so it looks like we have just about run out of time. So I will pose one more question that came in. And the question was, can the instrument measure KD and B22 values directly, or B22 has to be derived from calculations?
Well, I mean, all of these, there are algorithms involved in converting signal strength and intensity fluctuations to the numbers that are produced and provided in the graphical analyses. I'm not a mathematician myself, and I'm certainly not a programmer, but there are complex algorithms that are involved in converting signals into numbers, which can be plotted graphically and show you the KDB22 analyses.
Thank you, Keith. And I think someone asked if we're available for on-site demos. The answer is yes. I think currently, if you have the ability to receive us, we will come out for demos. But otherwise, we can do remote demos virtually. You can send in samples, and we'll run your samples in real time, and you can actually follow along as we do so.
And let me just add, I'd be delighted to visit customers even at this stage in the pandemic. I'd be delighted to do so. I'm itching to do so. So if you're able to accept me, I'm willing to come.
Excellent. Thanks to everyone for coming in and for joining us. Thank you, Keith, for all the great answers and for a good presentation today. That was fantastic. I also want to thank everyone who joined us live today. I think with just so many of us working remotely, it's a great time to explore new tools, ideas, and look for solutions to problems. So if you'd like to have a deeper conversation with our team about the lunatic, the stunner, I have seen some of your questions. We will answer to anyone whose name and email we have. But if we don't have your email, if you're logged in anonymously, feel free to send an email to info@unchainedlabs.com, and that will come to our technical team at some point, and we'll answer usually within 24 hours. And our team would love to also connect with you individually or with your company over Zoom and discuss exactly virtual demos or any technical questions that you might have on our instruments. We've done quite a few virtual demos right now. We have a few coming up. We have webinars coming up. And a bunch of other content that is now on demand, so you can access it directly from our website at unchainedlabs.com. So thanks again for attending the virtual seminar, and I hope you have a great rest of the day. So thanks, everyone.
And let me add, thank you very much. Stay safe, and I hope to see you all very soon.